am Prasad. Welcome to my Professor Spark channel. Now we are going to discuss about the introduction of uniform velocity and uniform acceleration. Suppose body moving in a straight line with a constant speed, then body is said to be uniform motion. That is nothing but uniform velocity. So here uniform motion is also known as uniform velocity. So body is moving with a constant speed. Suppose its speed is u meter per second. So 1 second it covers u meters. For t seconds it covers u into t. So the body covers a displacement that is ut. So displacement is equal to uniform velocity into time. This formula mostly used in case of uniform velocity. So what is mean uniform velocity? Look here again, we discuss body is moving with uniform speed in a straight line. Then body is said to be uniform velocity or uniform motion. So under uniform motion, we have only one kinematic equation, that is displacement is equal to uniform velocity into time. Next, let's go to uniform acceleration. Before going to discuss about acceleration, so what is the definition of acceleration? Acceleration means change in velocity per second. See here, acceleration means change in velocity per second or rate of change of velocity. In the motion, suppose velocity is changed, then definitely there is acceleration. Suppose body moving in a straight line, its speed is changed. For example, we observe different speed at different times. Suppose at the t is equal to 0, body speed is 2 meter per second. At t is equal to 1, body speed is 3. At t is equal to 2 seconds, body speed is 4. At t is equal to 3 seconds, body speed is 3. See here, for every second, see, for the first second, change in velocity is 3 minus 2, that is equal to 1. So next second, change in velocity is 1. Next second, that is 3 minus 4 minus 1, here decreasing. Whatever speed is increased or decreased, definitely there is a change in velocity because here magnitude is changed. So in such a case, change in velocity per second, that is considered as acceleration. So here for first second, its acceleration is 1, and the next one is 1, and the next one is minus 1. Suppose body moves in circular motion with a constant speed, suppose 3 meter per second. So speed is nothing but here magnitude. So at this the position, direction of the body is along this one. Suppose body is here, so direction is, this is one. So what is this? Tangent line. So tangent line means a line touches the curve. So what is the curve here? Circle. With the help of the thread, forcefully move the ball in circular path with my finger. Body move in circular motion. Suppose body at this the position, the thread is cut off. Thread is cut off, then body is moving along this line. So this is tangent line. Suppose body is at the position, body moves along this line. So like this one, see here, from the point to point, direction is changed. So length of this tangent line is nothing but magnitude. Suppose we take here 3 meter per second, length of this tangent line is 3 meter per second. So from the point to point, here direction is changed. When the direction is changed, vector is changed, because vector considered both magnitude and direction. Both magnitude and direction. So here direction is changed, immediately vector is also changed. So magnitude is constant, but here direction is changed. In such a case, vector is changed. What is the vector here? That is the velocity. So velocity is changed here. When velocity is changed, definitely there is acceleration. In magnitude or direction, anyone is changed here, then there is change in velocity. In such a case, there is acceleration. First, we go to discuss if only magnitude is changed but not direction is not changed. In such a case, how to calculate the acceleration. Suppose body moving in a straight line, its magnitude is changed. So its speed is changed for second to second. Magnitude is changed, definitely there is acceleration. Change in magnitude is also are two types. Suppose I take two cases. See here, at a different turns, first at t is equal to 0, body speed is (2 meters per second). At the t is equal to 1, say 3 meters per second. At t is equal to 2 seconds, body speed is 5 meters per second. At t is equal to 3 seconds, body speed is 4 meters per second. Look here, for every second, how to observe this change in velocities. First, in the 1 second, so it is increased by 1, again increased by 2, now decreased by -1. So these are not, change in velocity are not same for every second. Then body is moving here, non-uniform acceleration. So this is case for non-uniform acceleration. Suppose for every second, now observation at a different times, body speed is suppose t at the time is equal to 0 second. Suppose body is moving from rest mean 0 meter per second. After 1 second, its speed is 3 meter per second. After 2 seconds, 6. After third, 9. After 4, 12. So like that one, speed is increasing. See here, what is the speed increased? For every second, 3, 3, 3. Change in speed is same. So here velocity is changed for every second, that is the 3. So here change in velocity is uniform for every second, then body is said to be uniform acceleration. Uniform acceleration. So here for every second its velocity is increased by 3, 3, 3, 3. So here acceleration is uniform. So the body is said to be here uniform acceleration. Not only increase if suppose body velocity is going on decrease. For example, so initially I observed the body speed is 12 meter per second, and the next 10, and next 8, next 6, next 4. Velocity is decreased by -2, -2, -2. So here acceleration is -2. For second, here velocity changed -2. So here acceleration is uniform. So this is uniform acceleration. So what is the acceleration here? -2. -2. So minus acceleration is also called deceleration. So minus acceleration is also called deceleration. Okay, so here body is moving with the deceleration 2 meters per second. So what is the deceleration here? 2 meter per second square. We have some kinematic equation for uniform acceleration. Kinematic equations give a relation among initial velocity, final velocity, displacement, time, acceleration. Here initial velocity represented by u, final velocity represented by v, displacement represented by s, time t, acceleration is a. So what are the kinematic equations? Body is moving in a straight line. At the time is equal to 0, its initial velocity is u, and moving with uniform acceleration a. After time t, its velocity is observed is v and covers a displacement s. What is the acceleration definition? Change in velocity per second. So what is the time here? T. So for t seconds, what is the change in velocity? Change in velocity mean final velocity minus initial velocity. So final velocity is v, initial velocity is u. So change in velocity per second. 40 seconds change in velocity is v minus u. I want 1 second. So that is v minus u by t. So for 1 second here change in velocity. So what is the change in velocity per second? That is acceleration. So this is acceleration. So a is equal to v minus u by t. So bring t towards this a side, then it becomes at, that is equal to v minus u bring this side, then minus u become plus u. So that is u plus at, that is equal to v. So what is the equation here? V is equal to u plus at. So this is kinematic equation. So one of the kinematic equation is v is equal to u plus at. Next, I want to calculate the displacement for uniform acceleration. For uniform acceleration, here velocity is regularly changed. So its initial velocity is u, final velocity is v. So its velocity is regularly changing from u to v, whether it is increased or decreased. I take one of the example. After that we discuss about the displacement. See here, I take some regular increasing numbers. For example, 2, 5, 8, 11, 14. So these are regularly increased by how much? 3, 3, 3, 3. So these are regularly increasing numbers. I want to calculation of average of all these terms. We know what is the average? Say sum of the numbers by number of the numbers. So average is equal to sum of the numbers. So 2 plus 5 plus 8 plus 11 plus 14 by how many numbers are there? 5 numbers are there. So by 5. 2 plus 5, 7 plus 8, 15, 15 plus 11, 26, 26 plus 14, that is 40, 40 by 5. So answer is 8. So what is the average here? 8. Now for this regularly increasing, there is a simple technique to calculate the average, that is initial plus final by 2. So what is the initial here? 2. Final number is 14 by 2. So we get answer is 8. So this is the average simple technique. So this is used for only regularly increasing or regularly decreasing. So for regularly increasing or decreasing, so what is the technique to calculate the average? That is initial plus final by 2. So you take so many examples, that is a regularly increasing number or regularly decreasing number, calculate average by using the formula total of observation by number of observation or initial plus final by 2, we get the same value. Okay, if you have any doubt, check taking so many examples. Okay, so what is the average here? That is initial plus final by 2. So average mean that mean it become uniform. Let's see here, average of all these numbers is 8. So 14 written as 8 plus 6. So 14 is nothing but 8 plus 6. So plus 6 is added to 2. So 2 plus 6, that is 8. So here 11 written as 8 plus 3. Now plus 3 is given to 5. Then 5 plus 3 is 8. See here. So what is the mean average? So each number is converted uniform. So average is nothing but here uniform. Initial velocity u, final velocity v. So body is moving uniform acceleration. So here from u to v, here velocity is going on regularly increasing. Then average become, I take here u plus v by 2. So here average velocity, that is u plus v by 2. Velocity is changed regularly. So take average here. So what is the average become here? U plus v by 2. So here average velocity here u plus v by 2. That means entire this the path, body has a velocity u plus v by 2. U plus v by 2. In both cases they cover same displacement in the same time t. So here in second case, body is moving with uniform velocity. In first case, body is moving with uniform acceleration. So in both cases, displacement is same. So in the first case, displacement is equal to in the second case displacement. So what is the second case displacement? We know, already discussed it just now before. For uniform motion, displacement is equal to uniform velocity into time. So displacement is equal to, what is the uniform velocity here? That is u plus v by 2. U plus v by 2. So what is the time here? T. So here S is equal to u plus v by 2 into t. So we have already one of the kinematic equation, that is v is equal to u plus at. Okay, look here, time is there. From this equation I take t as a subject. So how do you take the t as a subject from the equation? So first bring u toward this side, then become v minus u at. So a bring toward this side, v minus u by a. So what is the time here? That is v minus u by a. Okay, here u plus v and v minus u is there. Okay, so this is formula appear as a plus b into a minus b. See here, so this is a minus b. So what is the a here? V. So v is a, u is b. Okay, so here v plus a is nothing but a plus b. So I take here v plus u. Okay, now see here, v plus u into v minus u, that is a plus b into a minus b. So what is that? A square minus v square. See here, that is s is equal to v square minus u square by 2a. U minus v into v minus u, they answered as u square minus v square. Okay, that is the wrong. So what is the reference here? V minus u. Okay, that is the reference. So this is u plus v is nothing but v plus u. Okay, so this reference is taken, that v minus u. So answer is v square minus u square. Okay, see here, then 2a prime toward this side, then it become 2as. So 2as is equal to v square minus u square. So finally we get v square minus u square is equal to 2as. Okay, this is second kinematic equation. So what is the first kinematic equation? V is equal to u plus at. Second one is v square minus u square is equal to 2as. So what is the next one? So what is here? S is equal to uniform velocity into time. So what is the uniform velocity here? U plus v by 2 into time t. Now what is the v? V is equal to u plus at. So instead of v here, I written as u plus at. So instead of v, I take here u plus at by 2 into t. Okay. Next, see here, s is equal to u plus u to u plus at by 2 into t. Next, s is equal to 2u by 2 plus at by 2 into t. Okay, so 2 cancel. Then bracket mean into, so multiply t with u and 8 into t, 8 square, so there is by 2. So to read conveniently, take here s is equal to ut plus 8 square by 2, 1 by 2 8 square, so 1 by 2 is nothing but half. So what is the here formula? S is equal to ut plus half 8 square. Okay, so here s is equal to ut plus half 8 square. So we have equation s is equal to average velocity into time. So s is equal to average velocity mean u plus v by 2 into t. Now I take u as a subject from v is equal to u plus at. Then see here, from v is equal to u plus at, I take u subject. So bring at toward this side, then it become v minus at is equal to u. Okay, so here s is equal to, instead of u I write v minus at plus v by 2 into t. Okay, then s is equal to v plus v, that is 2v, v plus v, that is 2v minus at by 2 into t. So this is written as 2v by 2 minus at by 2. Okay, so 2 cancel, so we get here v. So s is equal to, so multiplied with a t, vt minus at square by 2. So this is s is equal to vt minus half at square. So this is s is equal to vt minus half at square. See here, suppose body is moving with uniform acceleration. So we have kinematic equations. What are those? Displacement is equal to average velocity into time. Average velocity is v plus u by 2 into time. V is equal to u plus at. Next, v square minus u square is equal to 2as. S is equal to ut plus half at square. Next, s is equal to vt minus half at square. So these are kinematic equation. Again, there is also, we need one of the kinematic equation. Suppose body is moving in a straight line. These are the positions at the different times. Suppose at the t is equal to 0, this is the position. At the t is equal to 1, this is the position of the body. At the t is equal to 2 seconds, so this is the position of the body. At t is equal to 3 seconds, this is the position of the body. at t is equal to 4, this is the position of the body. S1 mean displacement covered in first second, S2 mean displacement covered in 2 seconds. So S3 mean displacement covered in 3 seconds, S4 mean displacement covered in 4 seconds. So what is mean displacement covered in second? That means second mean it coming from 1 to 2. So we take the position from t is equal to 1 to position at t is equal to 2 seconds. So this is the displacement. So this is S1, this is S2. So this is displacement covered in second. So this is displacement in second. Look here, as second mean displacement covered in second. So initial at the position is S1, final position is S2. Okay, so this is S1, from S1 to S2. So I take here, this is total S2 and cut S1. From the total S2 cut S1, then we get the second displacement covered in second, that is S2 minus S1. Okay. So what is the displacement covered in third second? S3 means displacement covered in third second. Initial position is S2, final position is S3. So displacement covered in 3 seconds mean S3, displacement covered in 2 seconds mean S2. So if you cut this one, okay, what is this S2? So cut this from S3, then we get displacement covered in third second. That means S3 minus S2. So what is S3? S3 minus S2. So S3 mean S3 minus S2. S3 mean displacement covered in. So S3 mean displacement is covered in 3 seconds minus S2 mean displacement covered in 2 seconds. Okay, so displacement is covered in 3 seconds mean S3. So displacement is covered in 2 seconds mean S2. So that is S3 minus S2. So I want Sn. So Sn mean Sn minus 1. Okay, S3 mean 3 minus 1, that is 2. So Sn mean n minus 1. Okay, n mean displacement covered in n seconds. Sn minus mean displacement covered in n minus 1 seconds. So this is displacement covered in n seconds. This is displacement covered in n minus 1 seconds. Okay, I want to calculate displacement covered in nth second. So Snth, that means Sn minus 1. So what is Sn formula? Displacement covered in seconds, displacement covered in t seconds. So one of the kinematic equation is ut plus half at square, but here t is nothing but n. So this is un plus half a n square minus Sn minus mean. Okay, so this is Sn minus 1. So yes, ut plus half at square. So t is nothing but n minus 1. So t mean n minus 1 plus half a t mean n minus 1 whole square. Okay, So this is Sn minus 1. Okay, now I expand the terms. See here, first un plus half an square minus, see here, multiply with un minus 1, then we get un minus u plus half a n minus 1 whole square. So what is that? N square a minus b whole square, n square minus 2ab 2n plus 1 square 1. Okay. Next, un plus half an square minus un minus u plus half a. I multiply half a with all these terms, then half a n square, half a into n square, half a n square minus half a into 2n. So 2 to cancel, so get here n, so there is minus into plus, that is minus an. Next, half a into 1, that is half a, so this is half a. Again next, un plus half an square, so multiply with the minus terms in the bracket, then minus un, minus of minus plus u, plus into minus, minus half an square minus an into minus plus an, plus into minus, minus half a. Okay, so half n square cancel, un cancel. Okay, remove all these terms. So these are the remaining terms. Then we get here u plus an minus half a. So this is Snth. So what are the remaining here? U plus an minus half a. So Snth is equal to u plus, I take a as the common here, then it becomes n minus half. Okay. Next, so u plus a, suppose I take LCM here 2 in the bracket, then that is 2, then 2n minus 1. Okay, 2 into n, 2n minus 1. So this is Snth is equal to u plus a into 2n minus 1 by 2. So I have written as a by 2 into 2n minus 1. So a by 2 is nothing but, to read convenient, half a. So this is Snth is equal to u plus half a into 2n minus 1. So this is Snth formula. Okay, see here, already we discussed the kinematic equations. So now include this formula. So what is Snth? That is u plus half into a 2n minus 1. So these are kinematic equations. Okay, for body moving in uniform acceleration, remember all these formulas.